Okay. So, good evening, guys. And yesterday, Wednesday was a public holiday, and so those tutorial batches or tutorial slots on Wednesday was lost. Okay. So I also lost two of my classes yesterday, and I know the tutor Yogeswaran also lost two of his classes yesterday, right? So the challenge for me is the synchronization is a bit of out of sync, because Tuesday I had tutorials, you also had tutorials, and we have covered the worked example, and we have discussed at least question tutorial 1A done, 2A done, and I have given a briefing about 1B, right? So for the benefit of the tutorial batches who missed the class yesterday, I have to teach something which has been covered for the Tuesday's batch. So Tuesday's batch, both under me and Yogeswaran, you have to tolerate, because I am going to repeat that has been discussed for you. Otherwise, the Wednesday batch, they have done only regular expression. They have not. I have not taught them, or better, they have not learnt NFA DFA yet. Okay, so we cannot discuss something new for them. It will be difficult for them to understand. Okay, so tolerate a bit, and once I cover NFA DFA for them, we will take questions that are not done by you as well on Tuesday. Okay? Yeah. All right. So Wednesday's batch, so you attend to me carefully, because this topic that I'm going to discuss today has been done already for the Tuesday's tutorial batch. Okay? So for them it may be a bit boring, no choice. Okay. So we are with tutorial 3, NFA DFA. So NFA stands for non-deterministic finite automator, and DFA stands for deterministic finite automator. Okay. So automata means, I have told you, machine. Okay, but here it is not a physical machine, it is an abstract machine or a mathematical machine. And when we say finite state, what you see here is actually state transition diagram. Okay, the diagram here you are seeing is called as a state transition diagram. Okay, so every bubble you see here, every bubble or circle you see here is called as a state. Okay, and when you say finite state, so here every bubble is called as a state. So how many states you have? You have 5 states, 5 circles. So there are 5 states. Okay, so each state actually represents a process. There is going to be some process with each state. So you will come to understand shortly when I explain this. Okay. So for a machine, for a mathematical machine, which is represented in terms of a state transition diagram, like as you see on the white screen here, the number of states will be fixed. Okay, the number of states will be fixed. It won't be infinite. Okay, that is why it is called as finite state machine or finite state automator. Okay, so under finite state machine or finite state automator, you have 2 types. Okay, deterministic and non-deterministic. What is deterministic and what is non-deterministic, you will come to understand when I explain this problem. Okay, it cannot be defined straight away. If I define it straight away, you won't understand. Okay, so I need to explain in the due course of action, then you will come to understand what we mean by deterministic finite automator and non-deterministic finite automator. So the finite means fixed number of states, finite number of states or fixed number of states. It is not infinite. Okay, so state means, so every circle you see here is a state which actually represents some process. Okay, all right. So the question is, just to recall, give a regular expression and an equivalent NFA for the language over A or B that starts with AA and contain the substring BA. So this is, up to here is one part of the question. Okay, so this part of the question says the language is made up of the alphabets A or B. Like our English language is made up of the alphabets A to Z. Okay, so for a language the alphabet set is represented with a mathematical symbol sigma. Okay, sigma in mathematics is also used for summation, but here in automata theory or language theory, okay, or compiler theory, sigma represent a set of alphabets. Okay, so for this language given in the problem here, the alphabet set is just two alphabets A or B. Okay, so the strings are going to be made up of the alphabets A or B. Okay, so what is the pattern of strings? So the pattern of string is every string is going to start with AA is a must. Okay, string should start with AA, and substring contains substring BA. Substring means part of the string. Okay, a part of the string is BA. Okay, so the string must start with AA, and part of the string, that's what we mean by substring, is BA. So between this AA and BA, we can have any combination of A or B, and after this BA, we can have any combination of A or B, and that's what we discussed. Okay, depending on the value of Kleene star, we will have strings. If both the Kleene star takes a value 0, we will have the string AA, BA, and that is what you see here. Okay, if both the Kleene star takes a value 0, so this part of the string will become lambda, empty string. This part of the string also will become lambda, empty string. Okay, so you will get AABA. Okay, this is a regular expression. Okay, when this Kleene star is 0, this need not be 0. When this Kleene star takes a value 0, this Kleene star need not take a value 0. Okay, so both the Kleene stars need not take the same value. Okay, they can take different values. Okay, so depending on the values of these Kleene star, we will get different pattern of string. But every string must start with AA and must have BA. Okay, so I have given a few examples here, just few examples here, just to see the pattern of strings. Okay, so since we have a regular expression, it is very easy to construct the machine. Okay, so see, when I construct the machine, I'm not constraining my mind. I am going to construct an NFA. I am going to construct a DFA. No. Okay, I'm just going to construct a machine. That's all. Okay. After constructing, I am going to explain that this is an NFA and what is an NFA and why it is an NFA. Okay, and then I will explain how to convert that into a DFA. Okay. So I'm going to quickly show you how to construct an NFA. Okay, observe me carefully. Those who have already learned this is a refresher for you. Okay, just refreshing what you have learned. Those who have learned on Tuesday. Those who haven't learned yet, that is on Wednesday yesterday, you missed the class, then you pay more attention. Huh? Yeah. So what I do is I just look at the regular expression. So the regular expression is AA followed by A or B Kleene star, and then we have a BA as a substring, and after BA again we have A or B Kleene star. Okay, so similar to grammar, in grammar I applied the same thought. So once I understood the problem, what I did, I generated example strings. Okay, so when I generated example valid strings, I always started with the smallest possible string. Next smallest. So I looked at a few example strings to look at the pattern of strings the language actually accepts. And next step, I wrote the rules, production rules, with the intention of producing those valid strings, and that is grammar. Similarly is going to be with NFA, DFA. Okay, I look at the smallest possible string and I construct the machine for the smallest possible string. Okay, then I improvise so that the machine can accept all valid strings, all possible valid strings. Okay, so my smallest possible string is AABA. Okay, smallest possible string is AABA. So I am going to look at constructing the machine to accept this string AABA. So when this AABA happens, when this Kleene star and this Kleene star takes a value 0, this will become empty, this will become empty, we will get AABA. So what I am going to do is, I am going to draw the NFA. Okay, so this means start state. Okay, a bubble or a circle or a ring, howsoever you want to call, you can call it as, and I put an angular bracket like this. I can put an angular bracket like this, or I can put an arrow symbol like this. It means this state is a start state. Okay? So I am going to force the machine to process AA and BA. Okay? So I write like this. I will explain why I am writing like this. So this means, so what is example string here? Example string here is AA, BA. This is the smallest possible string. Okay? So this string is going to be given as input to the machine. Here the machine is non-deterministic finite automaton. Okay? So when this machine is given as input, I have explained this to the tutorial batches on Tuesday. I don't know whether Yogeshwaran explained this to you or not, but I'm explaining you. So those who are with Yogeshwaran on Tuesday, this applies, what I'm explaining to you now applies to you guys as well. Okay? So when I give this as input, because this question comes a lot of time to students. When I give this as input, this A goes first into the machine, or this A goes first into the machine. Okay? So we guys in English, we read from left to right. Okay? So we read from left to right, right? So when we read left to right, this A will go into the machine first. That is, this A will be given as input to the machine first. So what I do is I label these states so that they can be easily referred to. Like we have names to be called or to be identified. Likewise, we have labels for these states so that they can be called or identified. So I'm going to give a label Q0 to this state, Q1 to this state, and Q2 to this state. Okay? So at Q0, which is a start state, this A is given as input. So when this A is given as input, the machine transits. Transit means changes state. Okay? Transit literally means travel. Okay? But here in machines, it is changing in state. Like you have a switch. There's no switch here. The mechanical switches, you have one near the fire extinguisher. It has an on state and off state. Okay? So when you switch, when you press the switch from off state to on state, there is a change in state. It changes state from off state to on state. So current passes through, and the electrical appliance is a light, the light goes on. If it's an air condition, the air condition start blowing cold air. Right? So same thing here. When we give A as input to the start state Q0, the machine transits from Q0 to Q1. That is, the machine changes state from Q0 to Q1. Okay? And now, this A is given as input at Q1. Okay? So when A is input to Q1, the machine transits from Q1 to Q2. Okay? So now I have B, right? So I'm going to give B as input to Q3, and B means the machine transits from Q2 to Q3. And then I have A. So A means the machine transits from Q3 to Q4. Okay? So I'm going to explain one more time. So what I'm doing is I'm going to give AABA as input to this machine. So here the state Q0, every circle here is called as a state. Okay? The arrows here, they are called as transition. Okay? Transition arrows. Okay? So arrows taking the machine from one state to another. Okay? So when I give this string as input, which alphabet, which character will be processed first? This A. So when this A is given as input to Q0, the machine transits, changes state from Q0 to Q1. When this A is given as input to Q1, because I am keeping this hand here for you to understand, the machine is currently in this state. Okay, the machine is currently in this state. So the next input is A. So A means the machine transits from Q1 to Q2. So the machine is now at Q2. At Q2, B is given as input. At Q2, when B is input, the machine transits from Q2 to Q3. So now the machine is at Q3. At Q3, the input is A. The machine transits from Q3 to Q4. So this is what I meant by process. Every state has a process. Okay. So who builds this process? We, through instructions. Okay. So now I'm going to put another circle here. So when there is two circles like this, you can see that it is called as final state. Okay. So this symbol makes this state Q0 to be the start state, and two circles overlapping like this makes this state Q4 to be the final state. Okay? How about Q1, Q2, Q3? They are called as intermediate states. States in middle between the start state and the final state. So they're called as intermediate state. Okay? So now I have processed this. I need to process all valid strings that are in this language. Okay? So let us take a couple of strings. Example string. So triple A, B A, A, B A, B. Okay? So here, let's see whether this string can be processed by this machine or not. So A means the machine will transit from Q0 to Q1. Machine is here. This A means machine will transit from Q1 to Q2. It is here. This A cannot be processed because at Q2 we have instruction for B. We don't have an instruction for A. This part of the string is here, and this part of the string is here. So this happens because of this A or B canasta. Okay? So this A or B canasta is after AA and before the BA. After AA and before the BA. So what I do is I put a loop here and I call this as, I label this as A, B, A or B. Okay? So what this means is, this loop means is, at Q2, if you have an input A or B, it can loop back to itself. Looping back to itself means there is no state change at Q2. So if the input is A, the machine remains at the same state. That's what this looping back means. Okay? So for this A, the machine will process it at Q2. It will remain at the same state. There is no state change. Huh? So now we have a BA. So now observe carefully, especially those who belong to 2 stage tutorial batch. Okay? I'm going to tell you, explain you now why this machine is NFA, non-deterministic finite automator. Okay? So you have an A here, right? So the machine processed it here, no issue. Now this B has to be processed. So B means B is given as input to Q2. B means the machine can go through this path, stays in the same state, or B means the machine can transit from Q2 to Q3. So for this input B, there are 2 paths. Okay, there are 2 paths. Okay, Tuesday's batch, you have to be very attentive because time is very short. Okay, we are already in the 5th week. Then a couple of weeks later, you are going to have independent learning week. You know, yeah, and don't forget, we have a lot of tutorials to cover. Okay, so we have no luxury of time to keep repeating the same thing over and over again. Huh? So you have to be very attentive. All right, so we are here, and the machine is here. So when B is given as input to Q2, the machine at Q2 can process this B going through this route or path, or going through this route or path. That is, for the input B at Q2, there are 2 different routes, 2 different paths. Going through this path or going through this path. So I'm going to explain both the path and show you what happens. Okay? So for this B, if the machine takes this path, this route, it transits from Q2 to Q3. Okay? Now the machine is here at Q3. The next alphabet to be processed is A. So A means the machine transits from Q3 to Q4. The entire string has been processed. Machine is Q4. This is the final state, halt and accept. Halt and accept means the valid string is processed by the machine and it reaches the final state. We call this as halt and accept. Okay? We know this is a valid string. So I am going to trace this for this route and see what happens. So first A, the machine transits from Q0 to Q1. Machine currently is at Q1. For the next A, the machine transits from Q1 to Q2. Machine is here. For this A, no choice. A means it has to take this route. It stays the same state, so there is no state change for A. Next is B. B means we took this path earlier. Now I am going to take this path. So if we take this path, what happens? B means it takes this path. The machine remains at the same state. There is no state change. Okay, B has been processed. Now A. A means there is no choice. It's only this route. This route means the machine processes A, goes to this route, stays in the same state. Now entire string has been processed. The machine halts at Q2 because no more alphabets to process. Entire string has been processed. The machine is at Q2. So a machine halts at Q2, we call this as halt and reject. Okay? The machine should halt only at the final state. Okay? If the string is a valid string. Okay? So here we know the string is a valid string, but if for B, if the machine takes this route, the machine halts here, so it becomes halt and reject. Okay? This is wrong. Okay? It should not halt and reject, it should halt and accept. So why this happens? Because of B here. So for the input B here, at Q2, there are two routes. Okay? So we call this as redundancy. Okay? We call this as redundancy. Okay? So redundancy means duplicate. So for the alphabet B at Q2, there are two routes. So B route is duplicate. Okay? So this redundancy actually causes this problem of one route leads to the final state, another route leads to failure. Okay? So if we follow this route, it leads to success for this string. If we follow this route, it leads to failure. So how the machine knows which route will lead to success, which route will lead to failure? The machine does not know. Okay? By itself, the machine does not know which route will lead to success and which route will lead to failure when there are more than one route. Okay? So the machine by itself cannot determine which route will lead to success and which route will lead to failure. So we call this as non-determinism. You understand? Okay, we call this as non-determinism. So what causes this non-determinism? What is the cause of this problem, non-determinism? B is redundant here. B redundant means there is a choice for B. This choice actually leads to non-determinism. So if we remove this choice, then the problem of non-determinism can be solved. Not only this problem, any problem in the world, we need to find the cause. If you are sick, you go to the doctor does a diagnosis and asks you, if you have a flu or a cold, he asks you, did you take any cold drinks? Then why he asks you this question? Because sometimes when you take cold drinks and during weather change or climate change, body temperature changes drastically or rapidly, it may lead to flu or getting a cold. Okay? So the doctor wants to find out what is the cause of the problem. The problem is you are sick. What causes the problem? Right? Same thing here. We have a problem here, that is redundancy. Not redundancy. We have a problem here, that is non-determinism. The machine cannot determine which path will lead to success, which path will lead to failure. What causes this problem? Redundancy. So if I can remove redundancy, I can solve the problem of non-determinism. Okay? So this machine that we have constructed just now is an NFA, non-deterministic finite automator. Fixed number of states, finite, automator, mathematical machine or abstract machine, non-deterministic, because for a valid string there may be more than one path. Some path will lead to success and some path will lead to failure. So which path will lead to success, which path will lead to failure, the machine cannot determine by itself. So it becomes non-deterministic. So second part of the question says convert the NFA you obtain to a DFA. Okay? So we are going to convert this NFA into a DFA. So I have given the explanation here. The criteria or the requirement for a machine to be a DFA. There are two conditions or two requirements. First requirement says every state must have an outgoing arrow for every input alphabet. Second requirement says a state must not have any redundancies. So I actually showed you the second condition. Okay? There is redundancy and we say we have to remove the redundancy. Apart from that, there is one more criteria, that is every state must have an outgoing arrow for every input alphabet to qualify for a machine to be a DFA. Okay? So if you look at Q0, let me show the condition so that you can refresh. Yeah. If you look at Q0, it has an outgoing arrow for A. It does not has an outgoing arrow for B. Condition 1 says every state must have an outgoing arrow for every input alphabet. Here there are two input alphabets, namely A and B. Okay. So Q0 has an outgoing arrow for A, but does not has an outgoing arrow for B. So what I'm going to do is, I'm going to take the arrow from Q0, label it as B, and I take it through a state called as error state. So I label this as E. E means here error state. Okay? You can even write in full error, but the bubble will become bigger. Right? And you may not have enough space on your A4 size piece of paper. Okay? So we just put the letter E to denote. E stands for error. So this state is error state. So why I am taking the B to error state? Again, remember, since this machine has an error state, it doesn't mean every DFA will have an error state. NFA will not have an error state. Only DFAs will have an error state, but not every DFA will have an error state. Okay? Because I know students, they always follow the Hertz policy. It's actually a management principle. Hertz could be a group of goats, group of lambs, group of chickens, group of deers, group of buffaloes, group of cows. All these are called in general as Hertz. Okay? Hertz policy means when a group of deers or a group of lambs want to cross the road, right, in the forest, what will happen is when one goat crosses, everyone else will just follow. Same thing happens to chicken, ducks, cranes, all these herds. When one leads, the other just follows. Okay? So the one that leads crosses when a vehicle comes. That's why there's a lot of hit and run with animals as well on highways, especially in the forest, right? So we call this as Hertz policy. When one fellow goes, everybody else follows. Okay? So this happens to students also, right? If one grammar has lambda, students expect, every grammar should have lambda. Not necessarily. Okay? Similarly here, if this question has an error state, it doesn't mean every DFA will have a error state. No. Okay? Nothing wrong in the Hertz policy. Okay? But it's just an example, that's all. Don't get me wrong that Hertz means there are something, bad. No. It's just, as I said, is a management, principle. Okay? Because they ask you, sometimes you want to be a leader or a follower. And don't forget, everybody cannot be a leader. And everybody cannot be a follower. It doesn't mean you are a leader, you are good, you are a follower, you are bad. But in general principle, certain times you have to be a leader, certain times you also have to be a follower. Okay? Yeah. Okay. It depends on how you want to balance it. There's a trade-off. Okay? Anyway, let us not go there into management principles, but I just want to say that in this example we have an error state, doesn't mean every DFA will have an error state. You will come to understand this as you work with more example problems. Okay? So why I am taking this B to error state? Because our question says every string must start with an AA. If a string starts with B, is an invalid string. Okay? Again, if you look at Q1, it has an outgoing arrow for A, no outgoing arrow for B. Q0 and Q1 satisfies the second condition. A state must not have any redundancies. There is no duplicate at Q0. Duplicate means an alphabet has more than one outgoing arrow. At Q2, alphabet B has two outgoing arrows. One outgoing arrow here, one outgoing arrow here. This is called as choice or redundancy. So at Q0 there is no redundancy. At Q1 also there is no redundancy. But outgoing arrow for B is missing. I take it to error state. Because first two letters has to be an A. First letter cannot be a B. Second letter also cannot be a B. So at Q1 I take the B to error state. The error state is also a state, and it should satisfy these two conditions, condition 1 and 2. So what I do, I take an outgoing arrow and I label it as A, B. This is same as writing like this. Luckily, here there are only two alphabets. What happens? We have 10 alphabets. We are going to see an example shortly. What happens? We have 10 alphabets, and we say A, B, C, D. We put the separate arrows. It will become very cluttery, like an ant colony. Okay. So to avoid clutter, so what we do is we just put one arrow and we label it as A, B. Never read A, B as A, B, because it is not a comma here. It should be read as A or B. Whether it is A or B, it loops back. That is, it remains at the same state. Okay? Certain materials, books or materials on the internet, they call the error state as dead state. Why it says dead state means, if you give a string like this, BA, 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 BA is an invalid string because it does not start with AA. Okay? It has the substring BA, but it should start with AA as well. So it's an invalid string. So if you give this string as input, B means it goes here. So once it goes here, no turning back. No turning back means once for a string, the machine goes here, it will never go to the final state. It will never. Because for this, for example, BA, BA, you give BA, BA here, B means it goes here, A, B, A. It will end here. Okay, any invalid string will end here. Okay? So, error state is also called as a dead state for this reason. Okay? So now, let us check Q2. At Q2, you have an outgoing error for A, outgoing error for B, condition 1 satisfied. But condition 2 fails because there is a choice redundancy for B. So one of the B has to be removed. Which B to remove? It's better to remove this B. Because if you remove this B, what will happen is, two problem arises. There is no instruction or there is no condition for the machine to move from Q2 to Q3. So at Q2, the machine will halt. It cannot go to Q3 at all. Okay? One reason. Another reason is, BA should be there. And that's why we had a B here. So it's not a good idea to remove this B, but we can remove this B. Okay, we can remove this B. So at Q2, I have an outgoing error for A, I have an outgoing error for B. Condition 1 satisfied. Condition 2 also satisfied. There is no redundancy. Okay, and at Q3, I have an outgoing error for A, I don't have an outgoing error for B. Okay, so tutorial classes on Tuesday, you have to listen to me carefully. There are two choices for me to have an outgoing error for B. I can loop it back here, or I can loop it back here. Okay, so this is same as this one. Okay, for certain problems we may need to loop it here. For certain problems you may need to loop it here, or certain other problems you may need to loop it here. Certain other problems you may need to loop it here. It depends on the problem. Okay, for this problem, is this right or this is right? Let us see. I'm going to show you. Okay, so I'm going to take an example string, something like this. AA is a must, BA is a must. Okay, so in between this AA and this BA, you have BB. Okay, let's process this string using this route and see what happens. First A, machine transits from Q0 to Q1. Second A, the machine transits from Q1 to Q2. For this B, the machine, no choice, no choice, the machine transits from Q2 to Q3. Q2 to Q3, yeah? Let me underline and show it easier. For this B, the machine transits from Q2 to Q3. For this B, the machine transits from Q3 to Q2. I'm using this route now. For this B, the machine transits from Q3 to Q2. For this B, the machine transits from Q2 to Q3. And for this A, the machine transits from Q3 to Q4. This B, there is no instruction here. Don't forget, after BA, we have an A or B, something like this. So we have to have a A or B here. So this B will be processed here. No issue. Okay. For this string, no issue. Let me change this example to AABB. So AA is a must, BA is a must. I remove this. Let us process this and see what happens. So now I am going to use this this route again. This route again. Let me remove this so that you don't get confused. You are going to use this route. So A means first A. So A means the machine transits from Q0 to Q1. Machine is here. A again, machine transits from Q1 to Q2. So B, no choice, machine transits from Q2 to Q3. B, machine no choice, this is for A. So B means machine transits from Q3 to Q2. A is process here, machine remains at Q2. A, machine process here, machine still stays at Q2. B, machine transits from Q2 to Q3. Entire string has been processed. Machine halts at Q3. Q3 is an intermediate state, halt and reject. But it's a valid string. You understand? So this route will work for certain valid strings, and for certain valid strings this route will not work. Okay? So, but if you look at this route it will work for all valid string. Okay? Let us process the same valid string with this one and see what happens. So A means machine transits from Q0 to Q1. Next A, machine transits from Q1 to Q2. This B, machine transits from Q2 to Q3. This B, machine stays at the same state, processes here, stays at the same state. So A means transits from Q3 to Q4. This A is processed here. This B is processed here. Entire string has been processed, halt and accept. Okay? So what I want to teach you here is, for B at Q3, okay, we can loop it here or we can loop it to the previous state. How do we decide? We have to do trial and error to see which works. Okay? So for this problem, you have to loop it here, this will work. If you loop it here, it will work for certain valid string it won't work. Okay? And that's what you're seeing here as the answer. Okay? So this is a DFA. Why is a DFA? It satisfies both these two conditions. Okay? And it is called as deterministic. Okay? DFA stands for deterministic finite automata. Fixed number of states, finite automata. Why deterministic? If you give a valid string, the machine will reach here, halt and accept. Any valid string in this language specification. Okay? Any invalid string in this language specification you give, the machine will halt here or it will halt somewhere here. Not at the final state. Okay? So you have a definite answer. Valid string, reach the final state, halt and accept. Invalid string, it will get halt and reject. It will stop at the error state or it will start anywhere else other than the final state. So you have a definite answer. Invalid string means halt and reject. Valid string means halt and accept. Okay? NFA means no. In an NFA, for a valid string, there will be situation where the machine will halt and accept. There will be situation where the machine will halt and reject. Okay? That's why in an NFA, you go and read the slide, I would have said that. For an NFA, for a valid string, there may be many paths. Certain path will lead to success, certain path will lead to failure. Okay? As far as there is at least one path that lead to success for a valid string, it is an NFA. Okay? So when we say deterministic, there is no choice. Okay? Valid string means halt and accept. Invalid string means halt and reject. So that's why it is deterministic. Okay? Well defined. Okay? Deterministic. Alright. So with this understanding, we will jump to question 1. Question 1, you have A, B, C, D. And if you see question 1, it says build an NFA separately for each that accepts the following languages. So for each of these, you are required to construct an NFA. Okay. Once you have done that, question 2 says obtain a DFA for each of the NFA built in 1A above. So meaning, for 1A you build an NFA and then you build a DFA for the 1A. For 1B you build an NFA. For that NFA you build a DFA. So question number 2 has 2A, 2B, 2C and 2D. Okay. So I know Monday's batch, we did 1A in the class. You did actually 1A in the class. I just checked the answer and confirmed your answer is correct. You also did 2A. And some of you already did 1B and 2B as well. But we stopped there. But I explained what is A, B, C and D. Okay. So what I'm going to do is, Tuesday's batch, Wednesday's batch, you did not go through 1A, B, C, D, right? So, Tuesday's batch also, they did not go through 1C, 1D yet. Even though I've explained what is 1C, 1D, they did not try in class. So, for the benefit of both the community, so we will discuss 1D, you do it. One of you can share the answer, so you are synced. If time permits, we will do 1C. Otherwise, I will explain what is 1C, 1B, 1A, and you can try it at home, and I will check in the next week's tutorial classes, the answers, okay? And will confirm whether you're right or not, all right? So that all the classes will be synced, okay? All right, I'll explain 1D. Let us quickly do 1D. 1D is a very simple question. The question says, strings over the digits 0 to 9 which have length 5 or less. So the example problem we solved, the alphabets are only A or B, okay? But here, with all these questions, the alphabets are not 0 minus 9, 0 dash 9, no. It is 0 to 9. That is, you have 10 alphabets. So here the alphabet set is your decimal number or decimal digits 0 to 9. Okay. Actually, for the decimal number system, there are only 10 digits, 10 symbols 0 to 9. You actually manipulate with the 10 symbols 0 to 9. Okay. Same thing with your binary number system. With your binary number system, there are only 2 alphabets or 2 digits, 0 and 1. Okay. With that 0 and 1, you generate any big binary number you want. Same thing happens with your decimal number system. There are only 10 symbols, 0 to 9. Same thing here. Okay. So, strings over digits 0 to 9 which have length 5 or less. Length 5 or less means you can have a single digit number, minimum. Maximum is a 5-digit number. Decimal number, single digit, or you can have 5-digit maximum. So single digit means, for example, you could have 0, you could have 1, you could have 2, 3, 4, 5, 6, 7, 8, 9, all single digit. Likewise, you can have 2 digits, you can have 3 digits, you can have 4 digits, you can have 5 digits at the maximum. When I put X, I mean don't care. Don't care means they can take any value from 0 to 9. This can take any value from 0 to 9. It can be 0 to 9, 0 to 9, 0 to 9, 0 to 9. So maximum is 5 digits. So meaning you have a fixed number of, here there is no infinite number of strings. You have a fixed number of strings. So what is your fixed number of strings? You go from 0 up to this is the maximum. Here, you can have infinite strings. Here you have finite number of strings. Okay? From 0 up to 99999, 5 digits. That's what the question says. 5 digits is the maximum. Length of 5. Okay? Can you construct it? And sometimes the students ask, can every state be a final state? Yes, every state can be a final state. You will see a situation later. Yeah, every state could be a final state. So you will see a situation later. Every state could be a final state. Can be a final state. Anyone want to come and share the answer on the board? So what I'm going to do is, I'm going to force the machine to go through the 5 digits. So 5 digit, right? One digit. How I said 6 states. I need to process 5 digits at the maximum, right? So 1 digit, 2nd digit, 3rd digit, 4th digit, 5th digit. This is the final state. So how many states you have? 1, 2, 3, 4, 5, 6. Because 5 digits, ma. Correct, right? So I can have 0, right? Look at the example, don't look at me. Right, I'm not a Shah Rukh Khan, huh? Very normal human being, so you need to listen to me. So you can have any of the 5 digits, right? Not just 0, right? So can I write 0 to 9? This has to be a final state, right? If I give 0, process, halt and accept. If I give 1, process, halt and accept. 2, halt and accept. 3, halt and accept. 4, halt and accept. 5, halt and accept. 6, 7, 8, 9. What happens? 0, 0. Five nines. First 9, second 9, third 9, fourth 9, fifth 9. 5 ones or 5 zeros. First 0, second 0, third 0, fourth 0, fifth 0. Just 1 digit stops here. Halt and accept. 2 digit stops here. 3 digits stops here. 4th digit stops here. 5th digit stops here. Done. This is the answer. NFA. Why is an NFA? Why is an NFA? Let us label this so that you can tell which state does not qualifies or does not satisfy the 2 criteria. Sorry? Where there is redundancy. If you observe carefully, Q0 has outgoing arrow for all the input alphabets 0 to 9. No redundancy. Redundancy means you should have 2 routes, 2 paths for the same alphabet. Q1 also satisfies both the conditions. Q2 also, Q3 also, Q4 also, Q5. No redundancy satisfies, but there is no outgoing arrow for all the input alphabets. Correct, right? At Q5 there is no outgoing arrow. Can I put an arrow, outgoing arrow like this to convert this to a DFA? If I do this, what will happen? If I do this, what will happen? Just see. Doesn't seem critical thinking. What does the question says? Question says the length is 5 digits, not length 5 or less, not 5 or more. Right? So maximum is only 5 digits. If I loop like this, I said here the number of strings is finite, fixed number. If I loop like this, the number of strings will become infinite. You can have length infinitely length string. You can keep on looping back. You know, never stops. You never stop. You can keep on. So you can have infinite number of strings and a string with infinite length. 9, 9, 9, 9, 9, 9, 9, never stops. Okay. You understand me? So it will break the given language specification if I loop like this. I cannot loop like this. So this is an NFA. Okay? Because there is no outgoing arrow for every input alphabet at Q5. Now we need to convert this into DFA. What to do? Exactly. Now you know this fella needs to have an error state. So take 0 to 9 and label this as error state. And this error state is also a state, so it should also satisfy both the conditions. Now it becomes a DFA. This is not a final state error state. So if you go beyond the 5 digits, it goes here. Get state or error state. DFA. Yeah? So let us take the attendance and then I will explain what is ABC for the, especially for the Tuesday's batch. Monday's batch I already explained, so no sure. Not Monday's batch. Tuesday's batch I already explained. Wednesday's batch, yesterday's batch I need to explain what is A, B, C. You can try at home. Same thing happened with the others. Yeah. So that we are synced. Let me quickly share the cams and then I will come back to that and then I will take any questions if you have. So next week tutorial we will just do continue with NFA DFA, but we will do question number 3 and 4. Okay, you can mark your attendance. So what we have done here is that this is a DFA. Yeah? If you don't have this part, it becomes analytic. Can I finish something? Can I finish something? Okay, can I finish something? So if all of you have taken, otherwise those are still marking, the code is here. Just give me a couple of minutes. Just give me a couple of minutes and then I'll take your questions. I want to say something as well before you all leave. Question A, it says strings over digit 0 to 9 which contains at least 3 ones. At least 3 ones means 3 number of ones. 3 number of ones means your smallest string will be 111. You can have something like this. As far as there are 3 number of ones, it is a valid string. Can I have purely ones? Many ones? Yes. Okay. So question 1 says your string must have at least 3 number of ones, not 111. 3 number of ones. Okay. Something like this. Okay. Yeah. So the smallest string will be 111. Question B, 1B is similar, slightly different. Strings over digit 0 to 9 which contain 777 somewhere in the string. 777 somewhere in the string means 777 somewhere in the string means your smallest possible string will be 777. You can have 0, 1, 2, 777 like this. You can even have 7, 6, 5, 4, 777, 8, 9, 7. Okay, or even 7, 7. That is, you can have a single 7, you can have a double 7, no issue. The requirement is you should have minimum 1 777. Okay, can I have purely 7s like this? Yes, you can. Okay, because this one it has many 777s. Many 777s are there. Okay, so it also a valid string. Okay, and C is opposite to this. C says strings of digit 0 to 9 which do not contain 777 anywhere in the string. Okay, which do not contain 777 anywhere in the string. Meaning, you should not have a 777 at all. So for 1B, 1C, sorry, 1C, I can have 17, no issue. I can have something like this 1, 2, 3, 4, 5, 6, no 7 at all, no issue. I can have 7, 5, 6, 7, 7, 8, 9, no issue. I can have 1, 7, I can have 2, 7, no issue. Only thing is, we should not see a 777 in the string. Okay? We should not have a 777 in the string. So that is 1C. Okay? So you try it at home, and in the next class, tutorial class, I will check that, and then we will go to discuss question number 3, and I will explain 3B and 3C, which is supposed to be done as take-home exercise. We will discuss question number 3 in the next class. Okay? So before you leave, I want to say something. Next Thursday, I will send an email because not everyone is here. Not those who are here, also not everyone is listening to me. I'm shouting a lot. I'm trying to be as loud as possible to get all of your attention. So next Thursday, we won't have class. My class, not the university classes, my class. Because I have a clash of appointment, I couldn't avoid that. But what I will do is, next Thursday's class, I will replace it on a Saturday, which will be on Teams online. Don't worry, because very difficult to get venue and bring all of you together. So next Thursday, we won't have class, but I will send you an email through My Times, a message to everyone, and send a Teams invite as well. Okay? So I will replace next Thursday's class online. Okay? 1 hour. But I will do it as a 2 hours class, so that replacing 1 hour, that extra 1 hour is to clarify any questions or doubts you have, you can clarify. Okay? That also will try to compensate yesterday's class that we lost for certain batches, both for me as well as Yogeswaran. Okay? The 2 hours will be for everyone on Teams. It will be also recorded, and the recording link will also be made available on My Times. In case you say I have an appointment with the king, I cannot make for your replacement class, you can go ahead, no issue. Later you can watch the video so that you don't miss the class. Okay? All right? Yes. So now